presentation today, this webinar. We have invited an industrial engineering person to come and talk to us about efficiencies and optimization. And I think one thing Saffost is good at is on the food side, all the ingredients and whatnot and food science. But we work in the food industry, we work in factory environments, and we want to be seen to support you guys as manufacturers with optimization. And this is the latest sort of methodologies globally which are being implemented in the operations management and supply chain management world. So I've connected with Ken and invited him to do an introduction on DDMRP. Ken has a very many years experience in supply chain management. He's probably better to introduce himself than I am. So I want to hand over to Ken and let him take you through this fascinating topic. And I just want to remind you all, if you do have questions, we do have a chat option. So please put the questions in the chat, and at the end of the presentation, we can refer those questions to him. And then you're welcome to contact myself, anyone at Saffost, or Ken himself, if this is something that you guys would like to explore further. So Ken, over to you. Thank you for joining us. We really appreciate your time to come and speak to us today.
Okay, okay, Matthew. Thanks for the introduction. If I can get my thing to, oh, there we go. All right, so this is me. There's a lot of words on there, a lot of certifications, etc. But I think it's just so safe to say that I've been involved with my own business, doing consulting and systems implementation and education in operations and supply chain for the last 35 years. And it's only recently that I've come across this methodology, which I've found is improving my clients' planning and materials management. And so I think it's pretty important. And I think by the end of this decade, if most companies are not using this methodology, they're going to find it very difficult to keep up with their competitors. So you'll get a copy of these slides so you can read through what we've got there. I spend most of my time on airplanes until COVID hit, and then we discovered we could do everything online. So I haven't really been on many airplanes since COVID. But two of the most important people as far as this is concerned are Carol Patak and Chad Smith. They're prolific authors. They've written a lot of books, and they came together about 10 years ago or more and developed this methodology. They both come out of manufacturing. Carol comes out of the aircraft industry as a planner. She'd worked for IBM and PeopleSoft. And Chad Smith, very, very involved in the theory of constraints. And we use a lot of the theory of constraints methodologies within this demand-driven as well. And they form the Demand-Driven Institute, which provides education for this demand-driven materials requirements planning methodology. So materials requirements planning, where did it come from? How long has it been around? Well, it really came to the fore in the 1970s when Joseph Orlicky wrote his materials requirements planning book. And materials requirements planning gave us some advantages. We got time-phased planning, we got level-by-level bomb explosions, bill of materials, that is, dependent demand planning, we got component synchronization, reductions in inventory, and improved priorities. And if you look in his book, when he published in 1975, he reckoned there was about 700 companies, mainly in America, that were implementing this methodology. And it did become the way of life for planning. But where did it come from? Well, it was conceived in the 50s. We knew that if we had a bill of materials for a bicycle and I wanted to build 100 bicycles, I could very easily calculate through the bill of materials how many nuts, bolts, washers, wheels, saddles, etc. that I needed. Unfortunately, we didn't have the computing power to do the thousands of calculations required. I mean, if you have one raw material and, if you got one finished product and half a dozen raw materials, you can do it on a piece of paper. But if you've got hundreds of finished products and thousands of raw materials, there just wasn't the ability to do that. So it was in the 1960s, about 1965, that a chap called Dick Lin wrote the first MRP algorithms for IBM. And I've had the pleasure of meeting Dick, and he really is the grandfather of all the planning we've done in the past. And I said, why did you make it so simple? He said, well, I only had 12K of memory to work with. And those algorithms that Dick wrote back in the 1960s are exactly the same as the algorithms you get in your ERP systems today. And as we say there, it was commercialized in the 70s when Joe wrote his book there, his MRP book. By the 1990s, most companies had a modest scale MRP system in place. And I put my first MRP system in. I was the project leader at the company I was working for at the time. That was in the late 80s, about 1988, 89, we put that in. And we had a reasonably successful implementation. But what's changed? Well, if we look at the world, what the world was like in the 1960s and 1970s, it is totally different today. So we're still using planning systems that were developed for a different world than we are in today. And we're living in this VUCA world where it's very volatile, it's very uncertain, it's extremely complex, and it's also ambiguous. And it's not about if something is going to happen, is when it's going to happen. Definitely something is going to happen. And the planning systems we've had in the past have really not taken this VUCA world into account. And if you look at what the world was like back in 1965, and I can kind of attest to this. I know I don't look that old, hopefully, but I was actually working in 1965. And when you look at the supply chain characteristics we had back in those days, totally different to today. I mean, the only technology we had was the telephone, the landline, and the post office. And I was working in the UK then, so the post office was a bit better than the South African one. But even so, that's all the technology we had. And if you look at what we have today compared to then, and we're still using the same planning tools, basic is a bit ridiculous. So our complex supply chain complexity has gone up enormously. Product life cycles have become very short. Customer tolerance time, people are not prepared to wait. They want their groceries delivered within 60 minutes these days. Product complexity and customization has grown enormously. Lead times have grown enormously. Forecast accuracy has actually come down rather than going up. With all the efforts we've done in forecasting, it hasn't really done anything. And we've got these pressure for leaner inventories, etc. So we're living in a totally different world from when the software we're using currently was developed. So supply chains have elongated and they've fragmented while customer tolerance times have dropped dramatically. Back in the 60s, I worked for a company in England making tin cans, and we bought local steel, made tin cans and sold them to the local canning industry. There was really very little global trade in those days. The disparity means holding stock in some strategic point is a must if we want to grow our sales. It also means that planning horizons have become much more remote from actual demand realization. And we've got these very much longer forecast horizons. Also, there are many products with shorter lifespans to manage, and many use common components and our common resources. And this means managing stock positions effectively is a must, but effective capital and resource to get effective capital and resource management. It also means that detailed item level forecasts are much more difficult to attain. And I've been involved in demand management and forecasting as well for the last 35 years. And it isn't getting any easier. Our forecasts are not getting any more accurate, and they will not. And we know that forecasts start out wrong. The longer range we look at, the more wrong they're going to be. And the more detail we put into our forecasts, the more wrong they're going to be as well. So we're on a hiding to nothing, really, trying to improve our forecasts. So how is this conventional approach faring for us all? Well, generally not very well. Let's look at a single SKU, and we can look at a single SKU, and there are 2 points or universal points with regards to a stock keeping unit or an item. We have point A here, where we have too little, or worse still, we have nothing and we've got back orders and upset customers. And over on the B side here, we've really got too much for our current needs. We've spent money on things that we don't really need at this moment in time. If we draw a dotted line between these 2 points, we end up with basically the return on your inventory investment. If you look down here at A, we've got no inventories, there's no investment, we're not getting any return. In fact, it's costing us money because we have to expedite things in. Over at point B, we're not getting a return on our investment because we've invested too much and it's sitting around costing us money. So ideally, between these 2 points, there's an optimal range here. And if we can get all our inventory items sitting as close as possible to that optimal range, we will be getting a maximum return on the investment we have made in inventory. And inventory in any business is generally the largest thing on the balance sheet. And we want to make sure that that investment we've made is giving us the biggest return. Unfortunately, and we've done this many times over the last few years, if we go into a warehouse and we look at all the SKUs in a warehouse, we find that many of them have got too little or we're out of stock. And there are many items over on the other side here where we really have too much. And what we find is that buyers and planners don't want to run out of stock, so they buy or make double to stay out of trouble. And we have very few items that are sitting in this optimal range here. And this is not a happy situation to be in. And typically we find that when we run materials requirements planning, or if you're just in distribution requirements planning, we find that 1 minute we're okay, and the next minute we're not okay. And then we get back to okay again. So we're ending up with too much of the wrong stuff and not enough of the right stuff, and then we're ending up with not enough of the right stuff over on this side, and it flip-flops from one side to the other, and this is not a happy situation for us to be in. So what are the 3 bottom line effects to a company? Well, we have chronic shortages, not enough of the right stuff. We have excessive inventories, too much of the wrong stuff, and just generally too much stuff. And we get these high expedite expenses and wastes. So if we're in a distribution environment, we're cross-shipping between depots because we've got the wrong product at the wrong place, or we're flying product in because we've run out again now, and we've got all these expedite costs. But maybe the real problem is at a slightly different level. Now, as I said, I've been involved with supply chain and Apex, particularly for the last 35 years, and we've always had this bullwhip effect in our supply chains. So what is the bullwhip effect? Well, it's the transference and amplification of variability in our supply chains in both directions. So I put a little food supply chain together here. We've got a farm, and we take some of the basic materials from the farm or products from the farm, probably some primary processing. They get made into an ingredient. Those ingredients then go into some packaged food. So as we send demand signals up the supply chain, we get this signal distortion. And we get the same thing happening coming down with regards to materials. So we get the supply continuity variability. So if the farm has a drought and they can't produce the products, then we have a product with processing and the ingredients and finishing up with the packaged food at the end of the day. And the more products or items that we have, particularly in our bills of materials, then the worse this effect is going to get. So a true solution really needs to be able to deal with this demand and supply distortion within our supply chain. This is really the killer in our supply chains, this bullwhip effect. We'll talk about how we can mitigate that at a later stage. But did we know that the basic MRP equation that was written by Dick Ling back in 1965 has not changed? The same algorithm is still in your ERP systems today. MRP was never designed really to manage stock. It was designed as a perfect make-to-order calculator. And that's why it nets to zero. So that's how I used to sell it to companies when earlier on in my career. I would say, boss, tell me what you want, how many you need. I'll tell you exactly what you want, and we'll end up with zero inventory. It doesn't get any better than that, of course, until something goes wrong, and then we don't have enough material. So MRP only produces a realistic schedule when these three basic assumptions are valid. The demand is known and it's not going to change. And we know that's not true. We don't really know what our demand is into the future. There is sufficient time to accomplish all the required activities within the customer tolerance time. The demand time fence in your MRP system is supposed to be set at that customer tolerance time, but how long are your customers prepared to wait? Well, if you're selling food, I don't want to go into the supermarket and put in an order for milk and wait for the cows to be milked and for the product to come through the supply chain. So our customer tolerance times have become exceptionally short, and we don't have time to accomplish all the required activities in that time. And of course, there's no variability in execution. When we are making things through our supply chain or moving things through our supply chain, there's going to be variability. Things are going to happen. So those three things are not true. And Carol and Chad wrote this book precisely wrong, telling us why our current planning systems are really not working for us today. So MRP and DRP, it doesn't fit the VUCA world that we're living in today. So the Demand Driven Institute has come up with what we call demand-driven materials requirements planning, and it was first articulated in 2011. Now, in 2011, well, I always say to people, have you ever been to a presentation that's changed your life? And I've had two, and this was one of them. I happened to be at an Apex conference in 2011 in America, and I went to listen to what Carol Patak was talking about. I'd known Carol from around the turn of the century. She was the Apex president, and I'd been president of SAPEX here in South Africa, and the Apex presidents loved coming out here. So I'd met her in the year around about 2000, and then I saw she was on the speaker list. So I thought, let me go and listen to Carol. At this point, I was getting so fed up with trying to get my clients to use their planning systems properly, and it just wasn't happening. And I was seriously considering retiring and going off and doing something else. I came out of that presentation, which is the first time Carol presented this methodology to the Apex community in America. And I said, there's no way I'm retiring. I'm hitching my wagon to Carol, and this stuff is exactly what I've been looking for. So since that point, I've been promoting this methodology, this demand-driven methodology. Well, what is it? Well, Carol says she's standing on the shoulders of giants, and she's known a lot of the people here, like Joseph Orlicky and his materials requirements planning, and the Womack and Jones and the Toyota production system, basically lean. Very involved with Ellie Goldratt in the theory of constraints, and Edward Deming as far as Six Sigma and reducing variation in your supply chain. She always says, we've moved from the land of or to the land of and. Now, back in the 80s, people were saying, well, I'm lean, or I'm just in time, or we're purely theory of constraints, or we're purely Six Sigma. You know, it was about or, but now it's about and. We can include all the best methodologies we've got here with some innovation to come up with a method to model, plan, and manage supply chains to protect and promote the flow. And that is an important word, the flow. We want to get flow through our organizations of relevant information and materials. DDMRP uses strategic decoupling points to drive supply order generation and management through a supply chain. So we want to position inventory correctly in our supply chain. we want to protect those positions so they never run out of stock. And then we want to pull from those positions. But we know the world is changing on a daily basis. And so we must adapt our system on a daily basis to take account of what's actually happening out there in our marketplace. And this methodology does that. So we have 5 components of a DDMRP system. First of all, we want to position inventory correctly. That's the strategic decoupling. Once we've decided where to keep it, we want to set the buffer profiles and levels. And I love that this diagram here of the shock absorber. It's like the shock absorber is taking the variability out of the road surface, particularly when we hit those potholes. And that's what we're doing with the buffers. We're putting in this this shock absorber in the buffers to take up this variability in demand. And then we want to dynamically adjust it. And we have systems where this happens automatically on a daily basis. We don't have to do anything. But we also have the ability to go in and put manual adjustments for things that we know are going to happen in the future. This then creates our operating model, which is continually adapting to what's happening out in your marketplace. And once we have that running, we can then do the demand-driven planning, and we can do visible and collaborative execution. Now, traditional planning systems are purely planning. We don't have any execution linked into that planning system. With DDMRP, we do. It's a huge benefit. So going back to our supply chain here that we were looking at earlier, let's say we put in a buffer of a strategic buffer between this processing and the ingredient step here. What happens is that transference of an amplification of the variability, as soon as it hits that buffer, it stops dead. And then it starts up again until it hits another buffer, etc. We have the same coming down the supply chain with the material continuity supply. As soon as it hits the buffer, it stops because we always have inventory in our buffer, okay? And then it'll start up again until it hits the next buffer. But there's another huge benefit is now that we're shortening planning horizons. So the planning horizons are only between buffers within the supply chain. And so it makes it a lot easier to do planning. I'm not going to go in this in detail if you come on the other courses and what have you, but we have 6 decoupling point placement considerations as to where we're going to put inventory in our supply chain. And just as a little example, this was a company that Chad was involved in way back, around about the year 2000. It's an engineering company, and they were purely make to order, and they were offering 8 weeks delivery time for the products that they were making. Well, they strategically buffered certain points in their internal supply chain here, and they got that lead time down to 1 week. Now, can you imagine what that does in your business? If all your competitors were all quoting 8 weeks for a make-to-order product, and then suddenly you come along and say, "No, I'll make it in a week for you." What's that going to do to your business? You're going to increase your business. You could even perhaps get higher prices. So MRP was never designed to decouple. It makes everything dependent, forcing these long planning horizons. And so we get this variability accumulation. Right, so now we've decided where to put the inventory. We now need to put a buffer in place there. And we've had buffers in the past with theory of constraints, but typically what we've done with those is we make them third as far as the 3 zones are concerned. In DDMRP, we calculate each zone independently, and it has a purpose. The green zone at the top is really the size of the orders that we're going to replenish for this buffer. And it also indicates, based on dividing that size by the ADU, how often we're going to be replenishing the stock in that buffer. The yellow zone is basically the primary coverage. That is our average daily usage times the lead time to replenish the stock. And the red zone is the safety. It is not, and I'll report, not safety stock. It doesn't work in the same way as safety stock does in our current systems. It is the safety in the system. It is there to be used, a bit like your shock absorber. When you hit that pothole, it's there to be used. Okay, safety stock is not there to be used. We have to keep that amount of stock in at all times, and it causes even greater bullwhip effect in our supply chain. So we have group settings or buffer profiles, which are based on the type of inventory that we're looking at and the lead time and variability categories. Then we need to know the individual part properties, like its actual lead time. Are there any minimum order quantities? If it's in a distribution supply chain, what's the location, and what's the average daily usage in this particular buffer? And this gives us calculations. I'm not going to go through the calculations here. If you want to know more about this, we can talk. We can put a workshop in place for you, and you'll learn a little bit more about how this works. So we calculate. Well, the system calculates the size of the buffer for you. So in this case, I've got a green zone of 300, so that's my minimum order quantity, and I've got a 357 in the yellow zone, and I've got 233 units sitting in the red zone. So the difference between MRP and DDMRP is MRP was not designed to manage stock positions. It was designed to be, as we said before, the most perfect order calculator. MRP nets to zero. DDMRP never nets to zero. One of the key points is you should always have stock in your supply chain. So it's not like safety stock, which is more like a fire extinguisher. A buffer is more like a firewall that you might have, for example, in your computer system that stops nasty stuff going from one side to the other. And we want to stop that variability and that amplification going up and down our supply chains. And a buffer does that. Once we've got the buffer, then we want to adjust it. Well, in this diagram here, this is over a period of about 6 months. This is the size of the buffer. The black line here is basically the average daily usage, and we can see over time it's grown, and the size of the buffer has grown. Obviously, we're selling more. There was a slight drop off here when the demand dropped off a little bit, climbed a little bit, and currently we seem to be in a zone where the demand is going down a little bit, so the buffers get smaller. But we also have the ability to adjust the buffers, particularly when we have very severe seasonality for our products. And again, we don't have time today to go into all this, but it all becomes a lot clearer if you look at the education, the demand-driven institute education. So critical differences here. Most conventional safety stock and reorder point systems, they're static and they're not dynamic. We set it and we forget it. Here, we're adjusting them basically on a daily basis. We're adjusting to what's happening out there in the marketplace. So when it comes to planning, we're moving to a more relevant demand signal. We're not planning on a forecast. We're planning on actual demand, which is a lot different. Okay? Sales orders and actual demand is highly accurate, whereas planned orders and the forecasts are extremely inaccurate. So we're going to continue with a more relevant supply order generation and equation. And typically there are only 2 new things we teach people in DDMRP, and this is one of them. And it's the net flow equation. And if you look at any planner, what are they looking to understand every day? Well, they want to know what's coming to them. What have I actually ordered, be it from the factory or be it from my supplier? What do I have in the warehouse at the moment? And what demand do I need to fulfill immediately? And is there any future demand that I know about that might be relevant? And so we've developed this new formula called the net flow equation. And this net flow equation is calculated every day for every buffer. All right. And what is the net flow equation? It is what have I got on stock plus what have I got coming into me, what's on open supply, minus any qualified demand orders. That is, what do I need to fulfill immediately? And is there any future demand I need to take into account? If that number puts me below the green zone, either in the yellow or the red zone, that's my net flow position. I then order up, or I get a recommendation to order up to the top of green. It's as simple as that. So every day you get a to-do list for those items that need to be replenished in your warehouse and in priority order. Those with net flow down in the red here are going to have a higher priority than the net flow ones in the yellow here. So you get a complete to-do list of what you need to replenish today, either from your factory or from your suppliers. So let's very quickly go through an example here. We've got a buffer, 35 in the green, 70 in the yellow, and 52 in the red here. We also have a threshold here, a spike threshold, where we look out to a spike horizon and see if there's any orders that are greater than that threshold. If they are, we will include them in the net flow calculation. So on the left here, I've got supply orders coming in, and on the right here, I've got demand orders coming in. And if you watch the animation here, you'll see on a daily basis, these are going to move in per day. So let's go through a quick simulation here. On day one, here we are, we're sitting with on hand 65. I've got two orders coming into me, 37 here and 35 there. So that's 72 I've got coming in on order. I've got a demand for 10 today, all right? So if I can calculate the net flow calculation, okay, it's on hand, 65 plus 72 on order minus 10, okay, that gives me a net flow position of 127, which is up here in the green zone. So that orangey arrow there is my net flow. My on-hand balance is sitting down here, okay, in the bottom of the yellow zone, which is where it should be, as we'll see later on. Okay, so as we go to day two, suddenly I've got an order that's come into my spike horizon here, which is typically my lead time of 30 units, which is greater than the order spike threshold I've set up here. So I'm going to include that order plus the 18 for today in the demand in my net flow calculation. So that my demand in the net flow calculation is 48. I still have the 672 in stock or on demand, on supply here. I will receive these 35 today, but at the moment they haven't quite arrived. So you see my net flow now has gone down into the yellow zone because of this. I've included this spike here. My on-hand balance is still sitting at the bottom of the yellow zone here, which is fine. So day three, I've received that 35. Oh, going back, sorry, to day two, I need an order recommendation of 98 because I need to order up to the top of the green zone here. So there's the order for 78 that I placed yesterday. I've still got that 37. So I've got 115 on order now. I've got to ship out 17 today, and I've still got that spike of 30. So that's 47. My inventory's gone down to 70. Well, my inventory now 72 because remember I received some yesterday and I did ship some as well. So my net flow is now sitting at a 140 up in the green zone, and my on-hand balance is sitting in the yellow zone here, where it should be. And we haven't got too much time to go through this, so I'm going to go through fairly quickly. But on a daily basis, we're calculating whether we need. On day 5, we don't need to order anything, okay? Day 6, I've got an order recommendation for 37 because my net flow went into the yellow. Net flow's gone back up to the green again, so on day 7, we don't need to order anything. Day 8, we don't need to order anything. Day 9, we don't need to order anything. Day 10, we don't need to order anything. The same in day 11. But when we get to day 12, net flow's gone back into the yellow again. So we've got an order recommendation for 40. And there's my 40 coming in. Okay. And there's day 14. And there's day 15. And I mean, this gets a bit boring because this stuff just really works. And there's day 16 and 17. And we've got, if we go back to 17 there, if you look in the bottom half here, you can see this run chart. And the top line here is my net flow. So every time it goes into the yellow, I send out a replenishment order, went into the yellow here, sent out a replenishment order, went into the yellow here, went into the yellow here. The black line down here is my on-hand balance. Now, the on-hand balance should fluctuate ideally in the bottom half of the yellow zone here, which it is typically doing, except we dropped into the red zone a couple of times, which is fine. It's not a problem. That stock there is there to be used. If we're not using it on odd occasions, then I'm in the wrong buffer profile and I need to change it. So if we look at some analysis here, we can see that the demand over the 17 days was 11.8 per day. We set that buffer up for 10 per day. And we got 18% more demand in that buffer, and it held up fantastically. We typically find that buffers will support an increase in demand of 25, 30% and still be robust enough to handle that increased demand. Also, we don't have too many points we can put on a graph here, but do you remember we were talking about that bimodal distribution where sometimes our inventory is down here at 0 and then sometimes we've got far too much sitting over here? Well, if you look at the number of days that the inventory was in a particular band here, you can see we're starting to form a normal distribution here, okay? Where the majority of the time, the stock was sitting in this optimal area here, which is where we want to see it. And again, we can see here that the average on-hand inventory was at a point sitting in the bottom half of the yellow zone, which is perfectly where it should be. So the planning for this item is working really nicely. But what about execution? Well, execution, we change the ways we look at priority, okay? With MRP and DRP, priority is always by due date. We don't have another way of doing it. With MRP, priority is about buffer status, okay? So in the factory, you could stick up a flat screen TV and project the buffer status of every finished product that you manufacture. And you don't have to tell the factory to do anything because they'll be in priority order. They'll be able to see which buffers are in the worst situation. In other words, where is my on-hand sitting down in the red zone here? If it's sitting in the red zone, this is a bit of a priority. Like in this example, I've got a purchase order here, which has only got 27% of the red zone left. So this is a bit of a priority. I need to go and find out from the supplier, where is this purchase order? Why haven't we received it yet? Can I expedite it? Here's a works order that we've only got 42% of our buffer left. This is a priority. If I'm a manufacturing planner, I need to go down in the factory and find out where's this works order. Otherwise, our buffer could be depleted of inventory. So we get a to-do list. We get a priority list. We know where we could have a problem in the future. So there's a nice list on the right-hand side here, manufacturing. I know what to make first. Well, I'm going to make this first order for Mr. Supertech because I'm going to invoice that. I can ship it and invoice it. But these other orders have got due dates on. But the most important one is for May the 14th. And these two down here were for May the 12th. And then I've got a May the 16th one. So forget the due date. Work on buffer priority status. So we want to say goodbye to this bimodal distribution, and we want to get the majority of our items sitting in this normal distribution in this optimal range. Yes, you will have items down on the A side here, too little. And we will have items sitting out here occasionally. And that's where we spend our time. We want planners and buyers to spend their time not worrying about this optimal range here. This is working fine. Just let the system do its thing. But go and focus on the tails here and find out why these items are sitting here and then get those tails to move in. And that's where we want people to spend their time doing that, not fiddling around deciding what to buy and what to make every day. So DDMRP is proven to allow companies to plan and execute in the optimal range at strategically chosen points. So we're starting to get happy faces coming out now. If we look into conventional, precisely wrong planning, this is how we've done our manufacturing planning in the past. We've had a sales and operations planning process, manufacturing material, master planning process here, and a materials requirements planning process here. And effectively, our sales and operations planning processes have been about projecting ranges. Yeah, look, if we're doing well, we could sell this much, but on the pessimistic side, we might only sell that much. But what we've done, we've taken a single number out of that range, typically the middle one, and we've used that to propagate down through the master production schedule and down through materials requirements. So this single wrong number is propagated down our planning systems. And when that number changes, which it will, we thought the customer wanted 100, but now he's ordered 120, everything changes. And it causes huge amounts of problems for planners and buyers. With DDMRP, we've got a sales and operations planning process still. Yes, there's the optimistic side, there's the pessimistic side, and we've got a forecast range, and we have a single number. We still take that symbol number, which is the projected ADU at each point in the future there, and we create that through master settings into a buffer. Okay, now that buffer over the next 12 months, we can see there, is also going to get bigger as our demand, we expect our demand to get bigger. But the beauty here is that we have a capability range in our buffer which we can reconcile with the forecast range in our sales and operations planning process. Okay, so the maximum inventory exposure, if things go pear-shaped and we don't sell anything, the maximum inventory exposure is your top of green. If we do exceptionally well, we can start eating into our red zones down here. So this is the maximum upside limit. So we can kind of reconcile this capability range in our buffer with the forecast range in our sales and operations planning, which we'd never been able to do before. So what we have is not a master schedule, but we have master settings. And that sends information down to our materials requirements planning system. We get variance coming back. So is the model working in the way we want it to work? If not, let's change it. And it's being adapted on a daily basis based on what's happening in the marketplace anyway. But we also have the forecasts coming down into master settings, and we have strategic recommendations on operational innovations coming back. So we now have a bi-directional sales and operations planning process, which we've never had before. And Dick Ling, with Andy Kolderick, his colleague, who was very involved in sales and operations planning and always said it needs to be two-way, but we could never get it to work with traditional planning system. Now with DDMRP we can, and Carol and Chad have pulled Dick back into the fold and got him working on this bi-directional sales and operations planning process. So what have we got now? We want to put into your organizations what we call the demand-driven adaptive enterprise. Now, again, we've got operations, we've got tactics, and we've got strategy. Now, down in operations, we've just been talking about this little bit here, the buffers. But if you've got a complex manufacturing environment, then you can put in time buffers and capacity buffers and finite scheduling and control points and all those lovely things. So the adaptive S&OP strategic portion of this model then sends business plans and parameters down to the demand-driven S&OP. This is your tactical point down here. We then create model configurations and master settings, and we send those down to operations. We then get feedback, variance analysis. Now you'll notice that the logo in the middle here, this demand-driven S&OP logo, is gold on the one side and blue on the other side. The goal is about, this is where we make our money, isn't it, in the factory? And so we want to make that working as best as possible. So we are continuously setting up the model configuration, seeing if it works, modifying it as we need it to make it work better. But at the same time, in the S&OP here, we're bringing in our demand plans and our forecasts. We're taking that operating model and we're projecting it into the future, and we're coming up with model projections, innovations, and strategic recommendations, which are going back to the strategic adaptive S&OP process. So now we have this bi-directional process within our business, which is really proving to be pretty useful. So what do we drive the operations with? Actual demands, not forecasts. Yeah, the forecasts are coming in the middle here. And what do we drive our strategy with? Well, basically what we've always driven it with, market-driven innovation. What customers do we want to deal with? What products do we want to manufacture, etc. So this was a chart put together by Camelot. They've gone and looked at a number of demand-driven implementations that have happened over the years. And we've not found a type of business where DDMRP doesn't fit. So it's not purely for the food industry, it's for every industry, from make to stock all the way through to make to order. We've got companies that make helicopters, Caterpillar are involved in this. Life sciences, medical, pharmaceutical, chemicals, consumer packaged goods. Overall, they found, Camelot, when they did the research, that those companies that have been implementing reduced their inventories by minus 32%. Okay. And the best was minus 70%. But I think the most important thing about DDMRP is improving your customer service. And on average, people were going up 13%. Best in class, going up 54%. And lead time reduction as well, minus 22%. On average, 85% best in class. And those are overall figures. So let's look at a few food industries and what they've achieved. Fruitlac. This is a company founded in Portugal. They've got 8 plants in 5 countries. They found they got a 25% reduction in inventory, and they increased their service levels to 95% and took out 1.5 million euros in working capital by reducing their inventories. Oregon Freeze Dried was probably one of the first, and Chad was very involved in this company over the Y2K period. They made freeze-dried food, and their demand went through the roof because everybody thought the world was coming to an end with Y2K, and they all rushed off and bought freeze-dried food to keep just in case. So it's one of the largest processors of freeze-dried food in USA, and they're also in Europe as well now. They got a 30% decrease in their raw material inventory. Their sales climbed 13 times, okay? And they only increased their finished goods inventory by twice. So they doubled their finished goods inventory, and their sales went up 18 times. Service level increased up to 98%. We've got another company here in Ukraine, tea and coffee manufacturers. There's quite a few companies in Ukraine actually using it. They had a very good set of guys implementing in Ukraine. Unfortunately, he's had to leave Ukraine now, and he's now a refugee in America, doing some brilliant jobs for demand-driven technologies. But a big tea company there. They reduced their finished goods and raw materials inventory. They got better customer service. They automated their planning systems, and they got a 60% increase in sales without increasing their inventory investment. And then we've got National Food Group here, wholesale food service distributor in the USA. They got a 7% increase in their on time and in full. Their inventory went down by 23%. They got inventory turns up to 62%, and they got 25% reduction in the time they took to do planning. And that's a big thing, You know, the first time we implemented this with a company in South Africa here, they were making the tracker systems that go into your car. And we got the planners in the boardroom and trained them, and they said, but this is too simple. What do we do after tea break in the morning? And they say, well, that's where you go and focus on those tails. We want to be using your valuable knowledge in improving the system, not worrying on a daily basis what to make and what to buy. But the biggest implementation we've got in Africa now is with Coca-Cola beverages. 8th largest Coca-Cola bottler. They do 40% of the African production. We've got it in 11 countries. There are something like 65 different plants and warehouses using this methodology, and it's all in one system. So the big boss at the top has got a big picture view, but he can go down into a particular country, or go to a warehouse, or go to a plant, or go to a planner, or go to an SKU at that plant. We can zoom right down and zoom right back up again. But interestingly enough, and they implemented around 2017, 2018. They found that out of stocks went from, well, in 2013 they were like 29%, 25%. They've gone down to 8 and 5%. On-time deliveries increased from 64% here to up to 83, 85%. But forecast accuracy hasn't changed at all. In fact, got even worse. Okay, so don't focus on forecast. You're hiding to nothing. But just listen to what Mr. Wicks has to say. Now, yeah, I think it's going to go for me now. Oh, there we go.
My name's Stephen Wicks. I'm the planning manager for Namibia, based in Windhoek. Adopting DDMRP was eye-opening from the beginning. The simplicity and ease with which it made the planning process really helped the team get into using it from the very beginning. If I had to summarize DDMRP into one word, it would be visibility. We are able to see at first glance the actual status of our raw materials and finished goods, which guides us in the right direction to do our replenishments in the right order, right priority, and to the correct buffer zones. We've managed to reduce our finished goods and raw material stock holdings, which has given us a great benefit of our working capital investment. We've also managed to reduce improve our days of coverage on imported materials from 14 days to 13 days, and on our own manufactured goods from 14 days to 11 days. All in all, it gives us a great ability to react to changes in demand, where before it would take a bit of time to figure things out. Now we know exactly where we're going and what the target is. It's given us a great amount of flexibility in our planning, and we no longer get surprises as we used to in the past.
Okay, so I would encourage all of you to go to Demand Driven Institute, all one word.com, and there you will find an enormous amount of information about the methodology, the education programs that they have, and the certification programs. Lots of case studies, lots of videos. There's a lot of information on there. And if you are interested, then I'm more than happy to give this presentation in your company if you want to. We do have a 3-hour basics of DDMRP workshop, which gives you a little bit more detail about how the whole thing fits together and how you calculate the buffers, etc. And that's free as well. We can do a simulation for you. If we can take your past data, your demand data, we can do a simulation over the last year and show you how the buffers would have reacted if you'd have been using this methodology over the last year, giving you the service levels, average inventory levels, etc. Again, that's a free service if you would like to take hold of that. If you want to really know more and become demand-driven certified, then we have a 2-day demand-driven planner professional program. which we can do online. And there's a certification program which you can take, the Demand-Driven Planner Professional. If your interest goes even further, then I'm also involved with Demand-Driven Technologies and their IntuiFlow software. So we can get your quotes, look at maybe a pilot project before a big company rollout, but you can go to demanddriventech.com for more information on that. Or you can contact me on that cell number there or on my email address. Or you can go to my web page there, which is demanddriven.co.za. So, Matthew, that's about all I've got to say. Did we get any questions?
Thanks, Ken. No one's had questions.
Stunned everybody into silence.
Yeah, it looks like it. If there are any questions, guys, feel free to load them on the chat. But yeah, I think as a food scientist and technologist, this is a topic which we always know about, but we don't work with all the time. We're the quality controllers, we're the policy guys, we're the, on the other side of things, and often the planners in the corner, they do the job, and it's good for us firstly to get a feel for that. And maybe we can take some of these type of pieces of information to the businesses to help them out to improve what they need to do. But it's great that you could expand our knowledge, and thank you so much for that presentation. We really appreciate it. Yeah.
Absolute pleasure. And yeah, if anybody wants more information, please contact me and we can have a discussion and see how we might help you to improve your business.
Yeah, great. Well, I think that sort of brings us to a close because there aren't any questions. There's been a comment from Alna saying thank you very much, very informative. So let's hope that people can get hold of us and see if they want us to come and do a demonstration or something. But yeah, thank you for attending, everyone. Thank you, Ken, and we'll have a chat about it again.
All right. Thanks, Matthew. Thanks, everyone.
Thanks. Cheers.
Bye.
Irene, I think we can close it all down.